Hello, welcome again to Geometry Section 4142, classifying triangles and the angles of triangles. Classifying triangles, excuse me. You can classify triangles in two ways, by their sides or by their angles. Classifying by their sides, we have the equilateral triangle, which has three congruent sides. We have the isosceles triangle, which has at least two congruent sides. It is of worthy of note that an equilateral triangle is also an isosceles triangle. So equilateral is a specific type of isosceles triangle, but isosceles triangle is at least two sides congruent. And we have a scalene triangle, which has no congruent sides. Classifying triangles by their angles, we have an acute triangle, which has three acute angles. We have an equiangular triangle, which has three congruent angles. And of course, if triangles add up to 180 degrees, an equiangular triangle has angles of 60, 60, and 60. There is a right triangle, which has one right angle. And lastly, we have an obtuse triangle, which has one obtuse angle. So classifying triangles, we can either classify them by their sides or by their angles. By their sides, they can be equilateral, isosceles, or scalene. By their angles, they can be acute, equiangular, right, or obtuse. Alright, definitions. Each point that joins the sides of a triangle is called a vertex. Adjacent sides of a triangle are sides that share a common vertex. If you choose any one vertex and not the two adjacent sides, excuse me, that should be not note, it should be not, and not the two adjacent sides, the side that is not adjacent is known as the opposite side. So if you choose any one vertex and not the two adjacent sides, the side that is not adjacent is known as the opposite side. We'll take a look at this picture here, kind of explain everything. Assume A is the vertex we are referencing. Okay, so we'll highlight A here. Each point that joins the sides of a triangle is called a vertex. We have vertex A, we have vertex B, and we have vertex C. The adjacent sides share a common vertex. So we have AB as an adjacent side, and we have CA as an adjacent side. And the side that is opposite of the two adjacent sides, or excuse me, from the opposite from the point and not of the two adjacent sides, is this opposite side. So BC is what's known as the opposite side. And this is just classifying, again, things that we may know, parts of a triangle. Alright, continuing on with definitions. In a right triangle, the adjacent sides to the vertex where the right angle is located are called the legs of a right triangle. The opposite side from the right angle is called the hypotenuse of the right triangle. We'll take a look at the picture here. So we have the adjacent sides to the vertex where the right angle is located. So we have our vertex at the right angle. We have a leg and we have a leg. The side opposite the vertex here is known as the hypotenuse. Okay, and this will come up more when we talk about trigonometry later in the year. In an isosceles triangle where only two sides are congruent, the congruent sides are called legs of the isosceles triangle. So taking a look here, the non-congruent sides of the isosceles triangle is called the base. So we have a picture that has the base of the triangle here. We have an isosceles triangle, and the adjacent sides here, these congruent ones, are the legs of the isosceles triangle. Alright, triangle sum theorem. Triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. Okay, and this demonstrates, the picture shows it. The triangle sum theorem states that measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So we kind of know that intuitively, but we do have a theorem that states it formally, that triangles, their interior angles add up to 180 degrees. A corollary to this theorem is a statement that can be easily a corollary to a theorem is a statement that can be easily proven using the given theorem. A corollary to this theorem, triangle sum, is that the acute angles of a right triangle are complementary. Meaning, if A is our right angle, okay, then angle B and angle C have to be acute. This is a right triangle. And since A has to be equal 90, then B and C added together have to equal 90 because we have 180 degrees in a triangle. So we can prove that corollary. And in fact, on our quiz, we're going to be asked to prove both the triangle sum theorem and the corollary to that. And speaking of the proof of the triangle sum, we'll take it now. So the triangle sum theorem, we can prove that the measure of angle 1, 2, and 3 add up to 180 degrees from the picture. So all we have is the given statement is ABC, and we're going to do something that you don't know. It's kind of like a new statement that we're just going to go with. But what we're going to do for our very first step is we're going to draw a new line, call it BD, parallel to AC. Alright, and we have our picture is changed in the right corner, and the reason why we can do this is the parallel postulate. The parallel postulate, if you remember back from section 3.6, states that through any point not on a line, there exists one line that goes through that point that's parallel to the line. So we've drawn BD, we'll put D on here, such that BD line and AC are parallel. And the nice thing about parallel is if we remember back to parallel lines theorems with transversals, we're going to have some congruent angles that occur from that. Alright, so we've drawn in BD being parallel to AC, and we need to make a statement based off of that. In the end, I want 1, 2, and 3 adding up to 180 degrees, and we'll take a look at what I can write. We can make the statement, seeing as how BD is a line, we've added angles 4 and 5 in there, that 4 plus 2 plus 5, those angles, all add up to 180 degrees. Okay, and the reason for that is the definition of a straight angle, and then if we add all the parts of a line, they add up to 180 degrees from the straight angle definition. So now I have 180 degrees in there, I have angle 2, and I have 4 and 5 involved as well. And what I need to get is I need to show that angle 1 and angle 3 can be substituted in for that statement so that they add up to 180 degrees. If I focus in on this statement here, angle 1 congruent to 4 and angle 3 congruent to 5, I can make that statement because if I have parallel lines, think back to our previous chapter 3, I have two Z's that are formed. One green Z and one black Z. And remember, the thing about Z's is that their corners are congruent. And their corners are congruent on both of them. And the reason why the corners are congruent on these Z's and through parallel lines is because they are alternate interior angles. So therefore, by the alternate interior angles theorem, angle 1 is congruent to angle 4 and angle 3 is congruent to angle 5. Now that we've stated that 3 and 5 and 1 and 4 are congruent, we know that they're equal to each other. So therefore, the measure of angle 1 equals the measure of angle 4, and the measure of angle 3 equals the measure of angle 5, and that's just because of the definition of congruent angles. With that being said, I have no problem then substituting in 1 for 4, right? Angle 4 here, go ahead and make this a 1, and angle 5, go ahead and make that angle 3 for my final statement here. And the reason, substitution property of equality. So by recalling some old stuff about alternate interior angles, because after creating parallel lines, we can state that a triangle adds up to 180 degrees on the interior angles add up to 180. Alright, next problem here. It says the diagram shows the path of a softball in a drill developed by 4 players. Find the measures of each numbered angle. So we have 2 triangles connected. We have 43 and 74 and angle 1 on the left triangle. 79, and 2 and 3 on the other. So I'm trying to find the measures of angle 1, 2, and 3. Well, thinking about what we just talked about, the triangle sum theorem, we do know that there are 2 of the 3 angles given for the triangle on the left. So we have 74 plus 43, which leaves us with 117. And there's 180 degrees total, so I can take that 180, subtract off the 117, and I'm left with 63 degrees for the measure of angle 1. So 63 degrees for the measure of angle 1. There is a relationship between 1 and 2. They are vertical angles, and we know that vertical angles are congruent, so therefore we know that that is going to be 63 degrees. We have 2 out of the 3 angles shown down for the triangle on the right, so we have 79 plus 63, and that's going to be 142. And out of 180 degrees possible, we can subtract off the 142, and we're left with 38. So therefore the measure of angle 3 is 38 degrees. So again, just using the triangle sum theorem to subtract and solve backwards for each one of the angles. And that kind of talks about it there at the answers, and also checks the result. Alright, same type of problem in the picture. So find the measure of angle 3. To find the measure of angle 3, we're going to have to find the measure of angle 1, and 1 and 2 are associated, then to find the measure of angle 3. So using that same pattern here, 67 plus 38 is equal to 105, and subtract that from 180, we know that angle 1 is 75, which means that angle 2 is 75 by the vertical angles. Then we can take 75 plus 48, and that's going to leave us with 123, and 180 subtract 123 leaves us with 57. So our final answer for angle 3 is C, 57. Next theorem, exterior angle theorem. Exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. Let's take a look at a picture here. Exterior angle theorem states that measure of angle 1 on the exterior of the triangle here, okay, highlighted in red, is equal to the sum of the inner 2 opposite angles, the non-adjacent angles. So we have angle A and angle B is equal to the measure of angle 1. Okay. Using that information, let us apply the exterior angle theorem in this problem. It says find the value of the exterior angle shown. So we know that we have the exterior angle here on the outside in green, that's 2x minus 11, and we know that the exterior angle is equal to the sum of the non-adjacent interior angles. So therefore we can state that 72 plus x is equal to 2x minus 11. So we have x plus 72 is equal to 2x minus 11. We can go ahead then and subtract x on both sides and add 11, leaving us with x as 83. And if we're looking for the value of the exterior angle shown, we'll take this 83 for x, replace it in for the exterior angle. We'll have 2 times 83 minus 11. That's 166 minus 11, or 155 degrees. Final answer, 155 degrees. Alright, next question. Find the measure of FLW in the fenced flower garden shown. So we have this fenced flower garden. It looks like FLW. We know that the alternate exterior angle theorems, or this, not the alternate exterior, excuse me, just the exterior angle theorem states that the exterior angle is equal to the sum of the non-adjacent inside 2, so therefore x plus 32 is equal to 2x minus 48. Alright, so we have x plus 32 equals 2x minus 48. We go ahead and subtract x on both sides. We add 48, and we're left with x equaling 80. We want to find the final value of FLV as we did last time, so we're taking this x equals 80, plugging it back in, and we have 2 times 80 minus 48, or 112 degrees. Same type of problem as the previous one. Okay, next problem. It says the piece of quilt fabric is shaped in the shape of a right triangle. Find the measure of ACD. So again, similar ideas here. The exterior angle is equal to the sum of the inside two. So we have x plus 90, because that's a right angle. X plus 90 is equal to 3x plus 10. We subtract x on the left and the right. We're left with 90 is equal to 2x plus 10. We'll subtract 10 on both sides. 80 is equal to 2x, and x is equal to 40 when we divide by 2. Therefore, final answer, B, 40. Alright, moving along. Using corollaries to find angles. States, the measure of one acute angle of a right triangle is 2 times the measure of the other acute angle. Find the measure of each acute angle. So breaking this down, the measure of one acute angle of a right triangle is 2 times the measure of the other acute angle. Find the measure of each angle. So we have a right triangle, which means we have a right angle, and the other two are complementary to each other per the corollary. So if we define the two angles that are left over as both x and 2x, then when we satisfy the requirement, it says that one has to be 2 times the measure of the other. So if we have one being x and the second one is 2 times that, we can make the statement then that x plus 2x equals 90, because again, if you have a right triangle, then the other two angles are complementary to each other. Simply solving then, we have 3x equals 90, divide by 3 on both sides, and x is equal to 30. So it says find the measure of each acute angle. We have one angle being 30 and the second angle equaling 60. This is the corollary to the right triangle theorem. Next one. The measure of one acute angle of a right triangle is 1/4 the measure of the other acute angle. Find the measure of each acute angle. So again, same idea. We have a right triangle, therefore the other two angles are complementary. So if one is x and one is 1/4 x, we can add those together and we'll equal 90 because they are complementary. So that would be this step here. We have x plus 1/4 x equals 90. Add those together, we have 5/4 x equals 90. Lastly then, we multiply by the reciprocal on both sides, so 4/5, 4/5, 360 over 5, simpling down to 72. So if one angle is 72, the second angle then is 1/4 of that, or 18. Final answer. Alright. Next problem says find the measure of the sides of an isosceles triangle KLM with base KL. So we have a base of KL. So that is the d plus 6. That is our base. And we have an isosceles triangle, therefore then KM is congruent to LM, which means they are equal to each other. The question says find the measure of the sides of the isosceles triangle with base KL. So we can make a statement that says that KM is equal to LM, which therefore will state that, if I slide this over, that 4D minus 13 is equal to 12 minus D. We would then add D to both sides, and we have the 5D minus 13 is equal to 12. Add 13 to both sides, 5D is equal to 25, and D equals 5. Once we know that D is equal to 5, then we can go ahead and substitute the value back in for each one of the lengths, here, here, and here. So the lengths of our figure, okay, our triangle, would be KM and ML being the same, 7, which is why they were isosceles, and then KL being 11. Again, isosceles triangles means that at least two sides are congruent, and in this case we had two sides congruent and one base. Alright, next problem says find x and the measure of each side of an equilateral triangle ABC if AB is equal to 6x minus 8, BC is equal to 7 plus x, and AC is equal to 13 minus x. So we want to find each one of the sides, and the sides of course come from the triangle being equilateral, and we know from definition that an equilateral triangle has all three sides being congruent. So once we find one of the sides, they should all be the same. We want to find x and the sides. So the first thing we have to do is, since we know that's equilateral triangle, we know that AB is going to equal BC. So we can just take 6x, not plus, 6x minus. So we have 6x minus 8 equals 7 plus x. Subtract x on both sides, 5x. We can add 8 to both sides, 15. X equals 3. Once we have x equals 3, we know that it can't be b and it can't be a. We can plug it back into any one of the sides, and we'll put it in for the first one, AB. We'll have 6 times 3 minus 8, which is 18 minus 8, or simply 10. So the sides are 10, which leaves us with the answer of C. Alright, next problem. Find the measure of each numbered angle. And this will be a problem similar to the one that we have on our test. Given the information that we have, we need to solve this figure for the missing angles. The first thing that we want to do is find an angle that we can actually solve for, given the information currently. If we kind of break it down into pieces, we can note that this green triangle here has 2 of the 3 angles completed for it. So I would start with that one at least first. We know that we have 41 down here, and we have a right angle that's 90, so 41 plus 90 is 131. So we have 180 minus 131, which gives us 49. So angle 5 is going to be 49 degrees. Alright, moving over to the other triangles. We know that not a number necessarily, but if we gave it a number, let's just call it 6. Okay, we know at this angle right here, angle 6, is part of the red triangle I'll draw in here, and this has 2 of the 3 angles. If I find out what the angle 6 is, I notice that 6 and 2 are vertical angles, and I'll have a nice start there. Alright, so if I can find 6, let's take 56 plus 48, and that leaves us with 104. And 180 subtract 104 leaves us with 76. So therefore this is 76 degrees. Vertical angles would tell us that 2 is the same, so that's 76 degrees. From there we can note that 1 and 2 are a linear pair, which means they are supplementary, which means adds to 180. So I know that angle 1 has to be 104 degrees. With that, I also know that the measure of angle 1 and this angle on the inside here are vertical angles, so this angle has to be 104 degrees as well. And if I have in the blue triangle here, I'll highlight in blue, I have 2 of the 3 angles now, so angle 3 would just be 104 plus 34, which is 138. Subtract that from 180, and I'm left with 42. So therefore the measure of angle 3 is 42 degrees. If I look at all of my angles, it looks like I'm left with just angle 4 now, and I had to figure out a way to solve for angle 4. Given the pieces that I have, I don't have necessarily this angle right here. Okay, that's if I'm looking at this small triangle right here. However, if I look at a larger triangle, we'll put it in black, this bigger triangle, I notice that I do have 2 of the 3 angles. Angle 3 here we just solved for is 42. We have a right angle, and now I'm left with 4, so therefore I have 90 plus 42, which is 132, and I have 180 minus 132, which leaves me with 48. Final answer for angle 4. So my answers reading across: number 1 is 104, number 2 76, number 3 42, number 4 48, and number 5 49. And that of course is what the bottom reads as well. Alright, let's take a look at our last example. It says find the measure of angle 3. And again, this looks very similar to what we're going to be doing for our test. If I look at this, it looks like I have to solve for several parts to get angle 3. I notice that 1 and 2 are vertical angles, and that's good. I know that I will need the measure of angle 4 as well to give me vertical angles here, or maybe a linear pair. Can happen, and I need to do work to get 2 out of 3 angles for this middle triangle. Alright, so starting off with some work, I know I need to add 45 and 85. That's going to give me 130. Subtract that from 180, that's 50. So measure of angle 1 is 50 degrees. Since vertical angles are happening here, that means the measure of angle 2 is also 50 degrees. Shifting over to the right here, this blue line means I have a linear pair, and if I have 135 on this part, I have 180 between the two of them. That means that this angle here has to be 45 degrees. And now that I have 50 and 45 for those two angles, I can add those together, which gives me 95. And if I take 180 minus 95, I'm left with 85, which is the measure of angle 3, and our result is C, 85. So breaking down this problem, like I said, would be very similar one we take on the test, but just using vertical angles and linear pairs and angle relationships to solve. Alright, practice problems that we're going to be looking at from this section are 15 to 37 odds on page 239, and on page 248, 1 to 31 odds, and 34 to 37. Thanks for watching.